Our project started with a simple idea. How could we accommodate people with disabilities in space? After some thought, we decided to hone in on vision problems. Over 2 billion people on Earth are either blind or visually impaired. For blind people, even the simplest of tasks, such as tying their shoes, crossing the street, or driving their cars, are either difficult or impossible. For many of these people, solutions to their eyesight issues can range from simple glasses to even sonar. But these solutions are hundreds of years old, and some, such as the walking stick blind people use, are completely outdated. With space colonization coming closer and closer to a reality, the fragility and reliability of these solutions in deep space and in extreme conditions, such as those of the Moon and Mars, are nothing but clear. In the past 24 hours, we've designed an alternative, Eyeonics, a glove that utilizes machine learning to help the visually impaired find their way.
Eyeonics is a glove that helps verbally alert the visually impaired of their surroundings. It was constructed using a Raspberry Pi 3, a plug-in USB Logitech camera, and an ultrasonic sensor, and was programmed in Python. The Raspberry Pi component of the glove also connects to a Bluetooth headphones or speaker to later communicate with the user. Every 5 seconds, an image is captured from the Logitech camera's feed and is encoded in base 64, and the ultrasonic sensor also calculates the distance in inches to the closest object in front of the user. After this data is calculated, an HTTP request is made to a backend server containing the base 64 image, the distance, and the current date and time. As my team members will later elaborate on, the backend server simply stores this data and uses a machine learning model to predict what the object from the image is, before returning it back to the Raspberry Pi on the glove. After this predicted object is received, an audio message is played through the user's connected headphones or speaker and verbally tells them what object is in front of them and how far away it is. And this is done to help the user know exactly what is in front of them and help them navigate their surroundings better. Now, before my team talks about the server and machine learning, here is a real demo of Eyeonics in action.
There is a piano 22 inches away from you. There is a door 48 inches away from you.
The backend server was made using the Rust programming language with the Rocket framework. It has 2 separate endpoints to accept data from the Raspberry Pi. The server uses a Docker container to deploy to Sharabh. Every 5 seconds, it receives, decodes, and saves the base 64 encoded image. Another endpoint sends the distance, current date, and current time. This code uses a foreign function interface to call the machine learning Python code from the endpoint's handler. The model identifies objects in the decoded image and returns the name and distance of the closest one. All of this data, including the values sent by the Raspberry Pi and returned by the machine learning model, are uploaded to a Firebase Firestore database. Finally, the values are returned through the endpoint to the Raspberry Pi.
The primary purpose of the machine learning model is to take the image data from the glove's camera and identify the objects near the user. It is a deep neural network that was made using Python and TensorFlow. The model used the OpenCV library, which allows for identification of multiple objects in one image. Various images were used to train the model, and tested if the model was able to accurately identify the different components of each image. Every time the server receives new data, the deep neural network runs a prediction iteration with the image and calculates the nearest object it detects. It then returns this to the server, which returns it to the Raspberry Pi.
But these advancements aren't just exclusive to space. With some spare change and some spare code, we can help the blind people on Earth find their way around. Right here, right now. Think of it this way. We're serving as the eyes of the people who need it the most. And all you need to do is lend a hand.